Hello, welcome to another episode of DevOps with Zach. I'm Arshad Zakaria. Today I have Shai Almog to discuss about Developer's Guide to Polyglot Debugging. So let's get started. Hi, welcome back everyone. Welcome to another episode of DevOps with Zach. I have Shai from Israel. So today topic is really going to be awesome because we are talking about the polyglot debugging, a total developer's guide to a polyglot debugging. And welcome, Shai. Thanks for joining with me.
Thank you. Nice to meet you.
Nice to meet you. So, Shai, can you brief about yourself?
Well, I've been a professional developer for about 30 years or so. Probably most people know me from my work at Sun Microsystems, where I mostly work on mobile and embedded, lots of open source code, etc. Founded Codename One in 2012. Wrote a couple of books, mostly related to that. I also did a lot of consulting for about 12 years or so, where I worked with lots of companies ranging from banks and everything about, I'd say, more than 100 companies all in all. And that kind of gives you a sense of the industry. Today, I also run Codename One, and I'm also a developer advocate for Lightrun, which is a continuous observability platform. Essentially, it lets you get remote debugging for servers in the way that they should be debugged. And as part of that, I'm working a lot with microservices and production related issues with customers.
Yeah, that's pretty awesome. So actually, I checked two books of you as well. It's pretty awesome. So if the audience, if you love to read about this book, so you can go and buy on Amazon. Right, Shai?
Sure, I'm not sure if they're appropriate for this particular audience, but go ahead.
Cool. So let's get started. So today we're going to talk about a lot of how these polyglot debugging help to the developers. And when it comes to microservices, it's a matter now. Everyone is talking about microservices. A lot of companies, and they're moving from the monolith application to microservices architectures. So when it comes to microservices architectures, it's really important that the developers, they use different languages for different services. They're not stick with one service. For example, if you're running a data intensive application, so your data calculation may be using Python, your API is using Golang, so it's a matter. So you need a continuous observability platform, a continuous observability plan to observe your application, how it behaves. So when it comes to debugging, it's really important how your application is behaving. So let's start with how we are debugging using native tools, Shai.
So that's a very good point here, and it's a very real world scenario. Like we have one of our customers at Lightrun here, which most of his code is actually in Java, but some of his code is in Python and even written with AirPlay, which is a whole different level of complexity where services sort of come and go and vanish and come back and forth. And there's literally almost no way to debug that other than Lightrun and tools like that. But I'm getting a bit ahead of myself here. Uh, when you're building a microservice architecture, essentially you're breaking down a monolith into smaller pieces, and part of that is a cultural shift within an organization where teams get split off into small pieces that are supposed to be completely isolated from one another, at least in theory. And in those cases, teams get a certain level of freedom in picking the tools that they use, all the way to the database operating system and programming language. And you end up with microservices that are sometimes, as you said, built in a multitude of different languages. According to the theory, there shouldn't be an impact because they're supposed to be completely isolated, completely self-healing. But theory is a very different thing from reality. So, as an example, in Java, we have null as a concept, which normally it's a much maligned concept, but personally I like it because null gives us very clear failures. When I invoke an object, try to invoke a method in an object which is null, I get an exception, and an exception points exactly to the area where the failure happened. Now, it might not be the original source of the null object, but that's relatively close usually. It fails relatively fast, and that's a core concept of Java, failing fast. And in my opinion, that's a very good thing for reliability in the long term, to fail as quickly as possible. Other languages sometimes have a very different abstraction for those ideas. And one such example would be in JavaScript, where you have the concept of undefined, which doesn't carry to other languages. So, in a case of such a system with different microservices in different languages, you might get a sort of pollution of bugs where an undefined from a Node.js server might traverse through servers and not fail because it's it doesn't fail as quickly as a null concept. And it might enter a Java server where we don't have the inoculation for that specific bug. We don't usually search for undefined in the database. We don't expect to see an undefined. We expect null. And that bug can keep propagating on and become very hard to find because the root cause was at a completely different server at a completely different time. We don't have a stack trace. We don't have that sort of incriminating breadcrumb trail that leads us back to the culprit involved. And that's a serious problem. And pretty much our only tool which we have as our only line of defense is logs, because essentially this is all completely separate and supposed to be completely isolated. But in reality, it's very difficult to truly isolate microservices from one another. The reality is that there's some environmental leak, and bad data can propagate, and unexpected data can propagate between services, and cause such problems. We can't possibly predict everything before we start building.
Yeah, that's true. So, what do you think about that? Now we're talking about the debugging, right? So we're talking about log shipping and stuff. Yeah. So yes, there are multiple tools in the industry that we can ship our logs, but correct me if I'm wrong. That again, it matters, right? Like, okay, what log we need and why we need. Like, rather there are like a lot of logs. It doesn't mean we have to ship all the logs to somewhere like a central place or maybe a log analytic tool. Again, it's impact your cost because logs means
Mhm.
data and transferring network, the IO as well. So again, it comes to when it's saving the logs. What do you think? It's like it's very important to save all the logs, or else you should know like what team and why you need. What are your thoughts about that?
That's a very good point. The cost of logs is tremendous in real world environments. So, one example is one of our customer which has over 1,000 containers, and just the cost of piping all of that information and keeping it and going through it in their log services is amazing. Just removing or adding a single log can have huge implications on their bottom line. So overlogging, which is the solution most services use today, is remarkably costly. Also, in performance of the servers themselves, which requires more services, which requires more logs, and sort of the problem compounds, kind of like sending a rocket into space. You need more fuel, so that you need a bigger rocket. You need a bigger rocket, you need more fuel, etc. The same thing applies for logs. And the costs here are a huge problem. And also, they make things harder to read. When you're actually searching for a problem at 2 a.m. and combing through logs, it's when there's too many logs, it's painful. When there aren't enough logs, it's worse. And the problem is when you're writing logs, you're not clairvoyant. You don't know what you should write in advance. and you can't tell where the bug will be, and you end up be going too far or logging too little, and it's just remarkably painful to get all of those ducks in a row.
Yeah, so that's the point, right? Like too much logs also not good. Same time, if you're getting the less logs, it's a disaster.
Mhm.
So where the point you find the middle, okay, what and why you need the logs and which logs you need, that's the hardest part. So definitely where the tools comes and helps to sort out these issues, right? So when talking debugging, we never forget about APM tracings, right? Because when talking about microservices architectures and the distributed tracing in observability, so APM is doing a pretty good job. So again, how you're guiding your developers that when it come to the APM tracing?
So APM is a wonderful tool. The dashboards are absolutely amazing. I think uh, we're always glued to our APM dashboards over here, and constantly, notifications, and we look always to errors and things like that. It's remarkably valuable. In one of my presentations just now, I literally classified APMs as sort of the bat signal, because that's literally what they are. They shine a light at the problems that we need to address, whether it's a performance spike here, CPU rising there, or errors on an entry point. And they really shine a light at the area that's causing a problem and helping us see where we need to focus, and literally feed us with all the big issue problems that we have. But where they don't go, and they shouldn't, essentially, it's not their job, is into the code itself. They're sort of high level tools that show us big problems. And if they would know which line of code to point us at, that would mean they need to instrument the entire code. And that's really, really expensive to do. So they don't do that. And what you need is tools for continuous observability, kind of like what we're working on at Lightrun, which is a continuous observability tool, a term I think coined by Tom Granot here. I'm not sure. And that lets us essentially pinpoint a specific line of code and essentially ask a question. So if we look at APMs are really observability tools. They get information about the server and tell us all sorts of information that's already available there, very valuable information, but sort of high level metrics. We can inject some specific metrics that we know of in advance, but still, the idea is that specific data that's already delivered is delivered into the APM. Continuous observability tools work more like a debugger, where you ask the server questions and the server gives you answers. And that's sort of like the way the debugger works. So you can add a log and literally print out a value of a variable. So in the case of a missing log, you can add a new log in runtime and add a printout to a value from the log, and you would see that value, that additional value. You can benchmark the performance of a specific method, a specific block of code, count the number of times it's invoked, etc. And that's very valuable to go beyond what the APM currently offers.
So, Shai, I have a question here. So, when talking about this continuous observability, right? So, when compared to APM, okay, let's talk about that the light runs, and when compared with another tool like Neuralink APM or Datadog, Dynatrace. So, what's the main difference between these things?
So we use them, we love them, they're great
Okay.
tools. And I don't think an APM is an observability solution. It lets you see very high level dashboard sort of problems. It lets you see entry points. It lets you see all sorts of information like that. Sometimes it seems very fine grained, but it's not line of code fine grained. Lightrun plugs into the developer IDE directly. So essentially, you open it in IntelliJ IDEA and soon in Visual Studio Code. And you literally, the developer opens his project and says, okay, wait a second, how many times is this line in this method invoked? And what is the variable value of this variable when user X invokes it? Literally that sort of question you can ask from the IDE, and you can ask it on a specific server. You can ask it on a group of servers based on tags, and you can sort of also get a snapshot, which is kind of like a breakpoint that doesn't break. So you can literally get a stack trace with the methods that invoked and the values of the variables, pretty much like a stack trace you'd get in a debugger.
So
And those those tools are more like a monitoring solution, like your process monitor in Windows, which is very valuable. Our tool is like a debugger, and those are great complementary tools. You won't use a debugger to see if your program is taking up too much CPU because it wasn't designed for that. But you will use the debugger to see, okay, my program is taking too much CPU. Now I need to find out, maybe that method is being invoked too often. Maybe that method is taking too long to run. And that's exactly the difference.
okay, okay. Now I have an idea. So basically, what happens is like mainly you go for the root cause and find the bottlenecks. Okay, this code of line or this code of the SQL queries taking more time execution. So maybe a
Yeah.
bad like
Mm-hmm.
someone has a bad while loop you're using there. So from that level, you can find out what's going on, right?
Exactly. It's like you'd
Wow,
use a
that's
debugger.
that's that's nice. Yes, so it
Mhm.
basically save the time of the developer to debug, because debugging is, I know it's very very annoying. It depends on the time. Sometimes we love debugging because we love to go dig and find what's going on. But imagine it's a production like a huge major down and
Yeah.
like a disaster. So then like these tools I think is believe, because when it comes to DevOps, it comes with the culture, practice and tools. So tools should make easier to use the culture and the best practices of DevOps. So these tools are really really remarkable. Yeah, I agree with that.
Yeah.
So
So debugging is one of the things that developers spend, according to Gartner, 50% of their time. And when I heard that, I said, well, it's stupid. We don't spend 50% of our time there. But then I
correct.
started looking at where I do spend my time, logging and stuff and writing tests to reproduce that and everything. And wait a second, yeah, I actually do spend 50% of my time debugging. And the thing is, a lot of that time is spent trying to reproduce stuff that happened in production locally. And with tools like this, we can essentially skip that. I can see the problem in production. I can reproduce it there relatively easily, or a user can reproduce it. So I can define the conditions that help me debug directly in the production, get the answer I need for the fix that I need. And then I can save the effort of debugging this locally or reproducing the whole thing locally. Now, this fits into the polyglot environment because I can essentially do that at scale and also apply things to multiple servers. So, for instance, in a case where a Node.js server in a polyglot environment, I can first of all put a snapshot there and debug that. It can invoke something on a Java server. Now, notice that each one of them is probably clustered to a very large amount. So, when I place a condition, I can put it on all of them at once. So, because I don't know which one of the servers will get hit. And I can get the information from all of the servers at once regarding whether a snapshot, which is our equivalent of a breakpoint, was hit. And that's a very powerful tool. You can do that on a per user basis using conditions on a breakpoint, on a snapshot, and get and essentially skip the guesswork of reproducing something locally, which might actually reproduce a completely different bug, which is something that happened to me quite a few times in my career, where a user reported a bug. I reproduced something locally, but it was a different thing. I fixed it, I upload it, and then the user says, no, the bug is still there. So these sort of tools give you a more realistic view.
And save the time, to be honest. Yeah. So I think
Hmm.
organizations such as like maybe a startup, maybe enterprise solution or SMB, then they're considering, are they going to get an ROI and spend something, some tools like this, right, to the organization. I think it's really important to do their own study and compare and go for such these tools, because if uh, if if they consider more about the finance side, money, and why we, okay, the main question we'll ask, okay, from the account department, when you trying to give the grant to accept to buy these tools. So why we need this, what's the importance, right? So there when there comes like then we should able to show that, okay, our developers is spending this much hours and we are paying for this much. And if you're going for these such a tools, and you can save some times, right? Correct me if I'm wrong.
So
So
developer time is a very valuable
very valuable.
thing to save,
Yeah.
and also developer happiness. But
Happiness.
I'd like to say that it goes well beyond that, because right now I said as we spoke before, overlogging is a huge problem, and it's something that literally has a dollar sign on it, a very large dollar sign in many cases. Now, the moment, as you know, in tools like this, you can inject logs. So why overlog? And if you just cut your logs just a little bit, just reduce them by a relatively small amount. And then if you actually do need that extra logs, you can inject them at runtime and see what's going on. Then you save a tremendous amount of money. You can reduce the amount of servers, you can reduce
Storage.
your spend on storage,
Correct.
it compounds. And we're talking millions of dollars in some of
Yeah,
the cases
definitely.
that we're talking about,
Yeah.
literally millions of dollars. So I think it pays for the product in those scales, easily pays for itself and pays for the salaries of a lot of the higher ups in the organization.
Yeah, correct. So when we are talking about the logs, right? So let's get one scenario like a debugging, debugging a specific authenticated flow. So related to, okay, some users having authentication and issues in the application. So what would be the best practices you would suggest, like debugging that flow specifically?
So authentication is one of the literally most painful things to debug. I literally wrote an article just now about it. It's still not out, but it's so painful, and it's something we always deal with. With Lightrun, it's relatively easy to just inject a breakpoint into the library that does the authentication. You can literally see the username and password coming in through the authentication server. This, by the way, is obviously risky. So you need stuff like PII reduction and blacklisting when you're doing that in production to prevent developers from maliciously going into that sort of code, which is something that we also support. So it's a very interesting but a completely very deep and different discussion. Uh, in terms of debugging that with a polyglot environment, you usually have a separate server that does all the authentication and authorization stuff. So usually you're working with something like Keycloak or Auth0 or Okta and stuff like that. And those guys in those environments, they usually provide a lot of tools to inspect and see where something failed. So if you're doing work on at scale with microservices, you'd have a key that would work on one server and then would let you essentially move between the servers, essentially a JWT uh, token that would let you go through. And lots of that code is replicated if you're using a single language. It obviously doesn't always replicate well, and uh, it's just a lot of wrestling, regardless of the technology you're using there. So, but the nice thing is we have great standalone solutions like Keycloak, like Okta, and everything that sort of separate out the pain. I don't think they solve it, but they separate it out. Um, I think
Yeah.
it's a very specific
Space.
solution
Yeah.
for
Yeah.
per user. So it's very hard to say something that's general about enough
Yeah.
about it
Correct.
that's true for everyone that I'm running into, because it's just banging your head against the wall with every separate customer.
Correct. Correct. And it depends on the infrastructure and the setup as well. Yeah. So yeah.
Mhm.
So let me ask you one thing last, like what are the when it comes to languages and platform differences. So that uh, some are saying the Windows and some are using Mac, iOS and Linux. So even though inside those applications, that which is running multiple platforms, it can be in same Microsoft's architecture in different environments. And again, when it comes to the polyglot debugging, so what are the tips that we can use?
So when personally, pretty much everyone that we've worked with, we have a few customers coming up with Windows now, but pretty much everyone is using Linux. Like it's uniformly dominant all over. And we literally just now came out with Windows support, like relatively recently. So I don't have enough experience to talk about debugging into that, other than historical experience, which doesn't necessarily stand the test of time. Especially today with improvements that they have with the Linux runtime, which is I played with that and it's great.
It's great. Yes.
Yeah. So personally, I use a Mac, and it's pretty much seamless to
Same
work
here. Yeah.
with Docker, and to work with. Also, we have a Mac native agent, and those things work relatively well. But obviously, these are Unix conventions and things like that. Most of the pain that I dealt with and ran into is in language related things, because when things pass between one server and the next, it's usually through a REST request, and you mostly see those type of issues when you're doing those calls. In fact, back in the day, we used to do things like connect to backend servers on AS400s and legacy COBOL systems, and that worked. It was even before the era of REST, so it was a completely different protocol, but things worked even for those cases with uh, with Java running on the AS400 relatively well. So operating system differences are, I think, mostly a solved problem for distributed systems today.
Correct.
Uh, we got that right by now, and I think REST really solved a lot of those problems relatively elegantly by being simple. And I recently was on a panel where we discussed distributed systems, and I'm a Corba guy. I had a ton of books about Corba, which are all defunct now by now, and OpenDoc, if people remember that stuff. Uh, it's essentially it's gone. It was a remarkably complex solution, which sort of evaporated in favor of a much, much, much simpler, ridiculously simple solution of REST, which essentially took over everything. And I think that definitely says a lot about KISS and how it's much better, even if the solution doesn't include two-phase commit and complex ideas like that. So I'm for that, and I think
Yeah.
that's
Yeah. True. Yeah, I have
mhm.
seen some companies they're using the VMs as pods or containers. That there are some companies they're like scaling, and I've read an article this related that they try to do the same scenario using VMs. It was really interesting use case actually. So basically, they're using even it's on AWS, and they're using even Spot instances. So which like they are kind of cutting their cost. Yes. So again, it's come to the when it's talking about that the language and platform. Yeah. So
Mhm.
finally, do you like to tell our audience anything like any best practices, any tips, any advices related to this?
Well, the best advice I can tell is don't do microservices. I mean, Martin Fowler probably says that best that do monolith first. You know, don't do microservices unless you really, really, really need to. I had recently a discussion about that on the internet where Vlad, his last name, I can't possibly pronounce it, said that microservices are a scam by cloud companies to steal our money. And I wouldn't go that far, but
Yes,
you don't want to necessarily go to build microservices because microservices are inherently harder to build, harder to maintain. And the same is true for a proper serverless architecture. It sounds like it makes things easier. It's serverless, it's sort of managed, but in reality, it's not. Just building a simple server is usually a simple small monolith is usually easier for 98% of the cases. And as you grow, as you scale, you will know when you need to pass to microservices. It will be felt, and you'll
correct.
have time to do that. You'll have time to do that. Don't rush into that unless you actually need it. And personally, I recommend standardizing on the language as much as reasonable. I know it's not always possible. There's mergers and things like that that make things harder. So it makes sense to sometimes do things like, for instance, it's really hard to find people willing to work on AI and things like that outside of Python. So I see people integrating Python pipelines with Java backends, and that makes sense because just in terms of hiring, if nothing else. So,
Exactly. So
but
it's kind of a
if
benchmark
you
made.
can. Mhm.
Sorry, I think kind of a benchmark they are made right for the hiring purpose. Like, okay, a DevOps engineer, or AI engineer, data engineer, asking for, okay, you need 10 years of Python experience to do this, right?
Yeah. Yeah,
Yeah,
pretty much.
pretty much. Yeah,
So yeah, I would recommend trying to simplify as much as possible,
correct.
and not because obviously we want you to, as a Lightrun employee, I want you to build very complex things so we can help you debug them. But as a Lightrun employee, that's a developer advocate that's supposed to help developers. I'm saying no, try to build stuff simpler. Need us for the tough things. Don't because you over engineered something, right? So that's when I see people like, for instance, writing about things like it's an anti-pattern to debug locally. I think, well, as I find that personally problematic, maybe because I'm old, I don't know. But as for Lightrun, it would be great if people don't debug locally, if they don't run locally their serverless applications, because we help them debug everything in the cloud. But personally, I prefer people take a more conservative approach
Be simple.
and be careful. Yeah, yeah. I'm a very conservative person when it comes to technology. I still like SQL. You know, I did a lot of object oriented databases in the 90s, and I learned my lesson. It's
That's true.
so I'm yeah, I was traumatized by that. So I'm for simple, proven technology, and it shows. Java guy. It's very much proven technology that works and scales and is well understood
I
and
think,
mature.
yeah, that's totally agree. So I think it doesn't mean that everyone is using Kubernetes. That's like you have to go to the Kubernetes, right? You can do it a simple way. No need to make things complex, like you mentioned. Especially if you're starting something, like, yes, you start with simple as possible. Then you learn with your historical data, and you can analyze and you can observe. Then you can, the application in and out. Then how its application is behaving, right? So then you can go for, if you really need, you can go for a microservices architecture. That's it's a good point, actually. Thank you very much,
Mhm.
Shai, for that. Yeah. And yes, it's a good it's really really pleasure to have you here, and it was a good chat. and we were talking about a lot of nice stuffs. So thanks again joining with me, Shai, today.
Thank
So have a
you. It
good
was loads of fun.
yes, thank you very much.
Okay, have a nice day.
Thank you, Shai, for joining today. And if you'd like to read the publications of Shai, please check the links in the description. I look forward to seeing you again with another episode of DevOps with Zach.